We are looking at the second variant of the same type, back titrations. The question comes with respect to calcium carbonate. Because we mentioned that if the reactant is volatile like ammonia or it is sparingly soluble like chalk, when you try to dissolve the chalk powder in water, you see they are not getting dissolved, right? So this applies to back titration. Their questioner is asking you for the percentage purity of the chalk here. You are provided with 0.125 gram chalk, 50 ml of 0.2 molar HCl in excess. The unconsumed HCl required 0.25 molar of 32.12 molar ml of sodium hydroxide. Calculate the percentage purity of the chalk here. So I am having chalk powder 0.125 gram. This is reacting with excess, which means it is not the exact ratio that it wanted. I am taking it in excess. Wantedly I am doing it. 50 ml and 0.2 molar. The unconsumed HCl was requiring 0.25 molar of 32.12 ml of sodium hydroxide. It has to calculate the percentage purity of the chalk here. So I know very well this unconsumed HCl can be calculated using the millimoles calculation of sodium hydroxide. So let's calculate the milli equivalents of sodium hydroxide. .25 into 32.12, that is 1/4 of 32.12, correct? Which is nothing but 8.03 millimoles of sodium hydroxide. Can I say that is nothing but the unconsumed HCl?
Yes, ma'am.
Yes? Alright. So if this is the unconsumed HCl, if I am going to subtract from excess, can I say how much of calcium carbonate, pure calcium carbonate was present in chalk?
Yes, ma'am.
Because
Yes, ma'am.
they said chalk. They are asking for the purity of chalk. What do they mean by that? The chalk piece that you are seeing right now is not just having CaCO3. It is also having some silica in it. It is having some other impurities in it. Some binders are there. Many are there. But these are not going to react with HCl. Which will react? Only calcium carbonate will react. So if I calculate how much of HCl was used by chalk, I can understand that is the milli equivalence of calcium carbonate for me. Can I say that?
Yes, ma'am.
Yeah. So I am calculating what is the excess milli equivalence. 50 into 0.2. This is molarity. Molarity into n factor. That is the n factor of HCl. Gives you the normality. I have 10 millimoles excess HCl. And what was my unconsumed? 8.03 millimoles. So this is the consumed equivalent moles, millimoles of HCl here. In other words, I can say milli equivalence of calcium carbonate is equal to 1.97. Can I say that? Children? Can I say this point? Am I audible?
Yes, ma'am.
Right. So I say that milli equivalence of calcium carbonate is 1.97. In other words, if I say equivalent moles of calcium carbonate is nothing but 1.97 into 10 power minus 3. This is milli. If I want to convert into moles, I should multiply by 10 power minus 3, isn't it? Your questioner is asking you for the percentage purity of the chalk. That means how much is the weight of pure CaCO3 with respect to 0.125 grams of chalk piece. All multiplied by 100 will give me the percentage purity. What you are having in your hand is equivalent moles. What is equivalent moles? Weight divided by equivalent weight. So I have calculated the equivalent moles here. 1.97 into 10 power minus 3 is equal to weight divided by equivalent weight of calcium carbonate. What is the equivalent weight of calcium carbonate? The molecular mass of calcium carbonate is 100 gram. Then what will be the equivalent weight?
50.
It will be 50 grams, right?
Yes.
Yes, so this is 50 here. From here I am calculating the weight. The weight is around 98.5 into 10 power minus 3 divided by 0.125 into 100. This will give us the purity of the chalk piece.